Alright, in this video we're going to take a look at some better methods of finding limits. So it isn't always the case that you can simply plug in x and get a good answer. And it isn't always the case that you can use your limit laws to work perfectly. So we're going to take a look at a couple examples. And the first one is the limit as x approaches 1 of x squared minus 1 over x minus 1. So straight away we're going to plug in some numbers here, and we're going to see that, well, 1 squared minus 1 is 0 over 0, and we say, well, we can't do that. That's no good. What do we do? Well, looking at it, it might not seem apparent, but we're going to introduce the first thing you can do, and that is factoring. Well, what do we know about x squared minus 1? This is where all your pre-algebra skills and pre-calculus skills are going to come into play. Alright, so x squared minus 1 is the same thing as the limit as x approaches 1 of x minus 1 times x plus 1, and that is still over x minus 1. Now, if you FOIL this out, you can check for yourself. You'll get x squared minus x plus x minus 1. These two things cancel. You get x squared minus 1. They're exactly the same thing. If you don't know how to factor that, you might want to watch a couple videos and refresh your memory on how to do that. So now the next thing we do is we then take the limit as x approaches 1. Well, we can cancel these two, so then we get x plus 1. And of course, if we plug in x equals 1, we get 1 plus 1, which is equal to 2. So the limit as x approaches 1 of x squared minus 1 over x minus 1 is equal to 2, even though at first glance it looks like it's impossible. But with factoring, you are able to solve it. Okay, question number 2. Again, we're going to go through these methods fairly quickly, and then I will pose a few practice problems that we can do together and we can see what's going on. Okay, number 2. We're going to take the limit as h approaches 0. We're not going to use x. We're going to get you guys used to different variables. Remember, these are just letters. They're nothing to be afraid of 3 plus h squared minus 9 over h. Well, if we plug 0 in, we're going to get the same thing. That's 3 plus 0, which is 3 squared is 9, minus 9 is 0, over h is 0. Once again, can't happen. So what do? Well, we need to figure out something else that works. So why don't we try our first thing, which is expanding that. Okay. This is the same as saying 9. Actually, hold on. That is very poor of me not to write the limit as h approaches 0 of 3 plus h squared, which is the same as saying 9 plus 6h plus h squared. And then we have our minus 9 all over h. Okay, well, let's collect like terms and simplify a little bit. So that's the limit as h goes to 0. Well, the 9 and the minus 9 cancel, so we get 6h plus h squared over h. And I'm going to put this in brackets since you don't necessarily have to write this out, but that's the same as factoring out an h. We can say 6 plus h over h. And we can see here that these two things cancel. So this is the same thing as saying that the limit as h approaches 0 of 6 plus h, which if we plug 0 in for h, then we get 6. So again, this is a very seemingly difficult problem. And these are expanding problems. And then you can get your answer just by expanding, collecting like terms, and seeing if you can get something nice. Of course, when you use these methods, you definitely have to have practice and looking at different limits and practicing a lot. That's when you'll eventually know how to utilize the right skill in the right moment. Alright, let's take a look at the third method, which will be the last method I cover in this video, with a seemingly difficult problem. The limit as t goes to 0 of the square root of t squared plus 9 minus 3 over t squared. Now here's what you're thinking. You're thinking, I can't expand this. I can't factor this. At least I don't think I can. So what do I do? Well, first step, let's check out to see if we can plug t equals 0 in and get anything good. Well, that's 0 plus 9, which is the square root of 9, which is 3 minus 3. Again, we get 0 over 0. Let's not even put the cross through it. We know by now we can't do that. So let's write something totally unintuitive. If you've never seen any bit of pre-algebra before, or you might have forgotten, you don't necessarily practice this a lot. So you might be thinking, what the heck's going on here? Well, here, we're going to do something. We're going to multiply by the conjugate. So what is the conjugate? If we have, I will explain this below here, the conjugate written like this, if we have the root of a minus some constant b, then the conjugate is the root of a plus b. So in this situation, we have this being our a, and this is our b. So we take minus and we multiply the top and the bottom by the conjugate. So here we're going to get the root of t squared plus 9 plus 3 divided by the same thing. And the question is, why do we have to multiply and divide by the exact same thing? Well, because we don't want to change the equation, so we're just going to multiply by 1. So if you divide the top by the bottom, then that equals 1, and you know, we're all happy. We don't want to change the equation. So multiplying by 1 is perfectly acceptable. It's just a very tricky way of cheating and multiplying by 1 to make the question easier. Okay, so we're going to multiply these out. So this is the limit as t goes to 0. Well, if we multiply the square roots, then the square root's going to come off, so we get t squared plus 9. And because it's of this form, we know that we're going to get minus 3, the root of t squared plus 9, plus 3 times the root of t squared minus 9, so those will cancel, and then we'll get plus 3 times negative 3, which is minus 9. And at the bottom, we're just going to write all the terms out, because I don't really want to start multiplying t into things. It's going to get a little bit confusing, and it seems a little bit unnecessary. In fact, most of the time, you're much better off not multiplying the bottom part out. Okay, so let's collect like terms. So we get t squared over t squared times the root of t squared plus 9 plus 3. Okay, well, see, here's why we didn't multiply out, because the t squared and the t squared on the bottom will cancel out. So now we get the limit as t goes to 0 of 1 over the root of t squared plus 9 plus 3. Okay, cool. And we can go further, and we can simplify it to a further step that is totally unnecessary, and we'll just plug t equals 0 in there now. Because, well, if we take a look, now we're going to get 1 over the root of 9 plus 3, which is the same as 1 over 3 plus 3, which is equal to 1 over 6. That's very cool. Now we have the answer 1 over 6, which is the limit of this equation up here. And I should give this a nice formal name for you guys. This is called rationalizing. So you rationalize either the numerator or the denominator. But in this case, what we really want to do is we're trying to get rid of this nasty square root, because we don't like square roots. When you multiply square roots by a square root, you get just a regular number to the first power, and that's what we want. So this is our motivation for rationalizing. All right, let's take a look at a couple practice problems. Number 1, let's try the limit as x goes to 5 of x squared minus 6x plus 5 over x minus 5. And what's another good one we can do? What about number 2, the limit as x goes to 0 of 2 plus h cubed minus 8 over h. Perhaps that'll be a little bit more interesting. So pause the video, see if you can do these, and I'll come back with the answers in a second. Alright, hopefully you got a chance to do them. So right away, because we're in this video, obviously these are going to come out to 0 over 0 because I like to trick you guys. And we're going to start off by factoring right away. So x squared minus 6x plus 5 is the same thing as x minus 5, x minus 1. You can check this out by multiplying them back together, seeing what you get. And this is all over x minus 5, which is the same thing as x minus 1. So I've been bad, and I haven't been writing my limits down, but I'm skipping them for now because it's faster to write them without them. So we take the limit as x goes to 5 of x minus 1 is equal to 5 minus 1, which is equal to 4. Awesome, that was pretty easy. Now the second one here, we're going to have to take the cubed function, which, I mean, it's honestly, it's a little bit daunting, so we're going to break this up into 2 plus h squared times 2 plus h minus 8 over h. There definitely are tricks to writing out cube functions faster, but we'll go through the thought process here and make sure that things aren't getting screwed up. So this is 4 plus 4h plus h squared times 2 plus h minus 8 all over h, which is the same thing as 8 plus 8h plus 2h squared. I multiplied all these by the first term, and now we'll do it by the second term, plus 4h plus 4h squared plus h cubed minus 8 all over h. Now let's start simplifying. Well, 8 and minus 8 will cancel, so then we have 8h plus 4h, which is equal to 12h. 2h squared and 6h squared is, well, 6h squared. And h cubed is just h cubed over h. And if we divide everything by h, then we get 12 plus 6h plus h squared. And now we take the limit as h goes to 0, which of course sends these two terms to 0, and then we get the answer is equal to 12. And you can check that in a graph. You can go to wolframalpha.com, check that out, and that is how you figure out these two questions. So hopefully you found this helpful. If you want more practice questions, there are tons online. I can even make another video if you're requesting them. We can go through some harder examples together. But hopefully you're getting familiar with these concepts and you can practice. You can create your own functions and you can see what goes on. Just make sure that when you have a function, it goes to 0 over 0. So let's say if you want to create a practice function, you can take, well, I want the bottom to be x minus 7, which means it has to be the limit as x goes to 7 to make the bottom that. And then we can say, well, x minus 7, let's multiply this by something, x plus 3. And then you get your question, the limit as x goes to 7 of x squared minus 4x minus 21 over x minus 7. And you can pass this to a friend and they can figure it out, and you guys can practice your limits. So that's the method of creating your own example questions. And it's good to familiarize yourself with the different types, so on an exam you know exactly what to do. But I'll see you guys in the next video where we will check out something a little bit more complicated.